Hello friends, in this video we will see more interesting topics related to input output. We were going into deep of input output exploring Java IO package. So we will start with new things related to this list files alternative. This is variation to the list method. Okay, so there is alternatives called list files which you might find useful more than list files. Okay, so signatures of list files are it gives file array, list of files, file array, list of files, file name, filter, filter object, file list of files, filter object, f object. This method return the file list as an array of file objects instead of strings. Okay, so it gives the file object, it gives the file array of objects of file class instead of strings. So there are not only name of files, there are objects of file type file. The first method returns all files and the second returns those files that satisfy the specified file name filter. Okay, aside from returning array of file objects, these two versions of list files work like either their equivalent list methods. Okay, so list methods alternative is list of files. Okay, the third version of list files returns those files with path names that satisfy the specified file filter. First will give you all files. Second will give you file names with the specified file name filter. Okay, so whatever the file name you will specify, depending upon that it will return the files, and those return the file objects but not strings. Other than this, there is no difference in between the list files and list file alternative. Okay, so there is only difference of array. First is returning array of file, array of string, and third this one is returning array of file object. Okay, the third version of list files returns those files names, path names that specify the specified file filter. Okay, file filter will give you only a single method accept, which is called once for each file. Okay, the accept method boolean accept file path returns true for files that should be included in the list, that is those that match the path argument, those are available at that particular path, otherwise those should be excluded. Okay, if you want to find out the files, suppose D drive XYZ folder, so all the files should be listed, those are included in that path only, other than that path those will not be included. Okay, creating directory. Another two useful file utility methods are make directory and make directories. These two are very common functions related to file handling in Java. Those are most popularly used, so that you will have them most of the times in the Java real world applications. First is make directory and second is make directories. Okay, the make directory will create a directory returning true or successfully creating a directory and false on failure. Okay, if you want to create a directory or folder by programming language, not by manually. How you create manually a folder in the Windows environment? You right click, go to new and create a folder. Okay, so in this case, if you are going to call this function make directory, it will create a directory for you at the particular path. Okay, so it is programmatically creating a directory or a folder in your any programming environment, any environment. If you are Windows, if you are Ubuntu, it is Linux. Okay, irrespective of that. Failure indicates that the path specified by file object already having, that is already existing, or that the directory cannot be created because the entire path does not exist yet. Okay, so file object or the file already exists at that path, it will give you a failure. And second thing, the path that you are giving to create a file at that particular place, the path is wrong or that path does not exist. You have to create a path first so that the file can be created at that particular place. To create a directory for which no path exists, use the make directories method. It creates both a directory and all the parents of the directory. Okay. If the parents are not present, for example, you are creating a directory at the particular place, say DXYZ. If the XYZ folder is not existing, so what make directories will do? It will first create the XYZ directory, and in that directory, it will make the other directories. Okay. The closable and flushable interfaces. With the Java 5 2 interfaces added, closable and flushable interfaces are implemented by several of the input-output classes. Okay, so two interfaces after Java 5 are added, and those are implemented by input-output classes. Their inclusion does not add new functionality to the string classes. Okay, so new functionality is not added. They simply offer uniform way of specifying that a string can be closed or flushed. Okay, so there are no methods available to be implemented by input-output classes by these interfaces, closable and flushable. They only provide a way of specifying whatever string you are using. You are closing a string either, or you are flushing or cleaning a string. Objects of the class that implements the closable can be closed. Okay, whatever class that is implementing closable, that class objects can be closed. Void close shows input output exception. This method closes the invoking string, whatever is the object, releasing any resources that it may hold. This interface is implemented by all the input output classes that open a string that can be closed. Okay, that can be closed. This is a very important line. Whatever strings object, those can be closed, those can only be closed in this case. Object of a class that implements flushable can force buffered output to be returned to the string to which the object is attached. Okay. Object of a class that implements the flushable can force buffer output to be returned. Whatever output is there to be returned to the string which we object is attached. Okay. So whatever is there in buffer, that will be returned to a string. If it is flushed, means it is going to be cleared. If suppose your stream is attached to a particular file xyz.txt and you are going to flush your stream object, so whatever is there buffered inside that buffered output stream, that will be returned to the file, and then the stream object will be flushed out. Okay, so that means that buffer will be clean and no longer it will hold whatever the data that you are holding now. Flushing a stream typically causes buffered output to be physically returned to an underlying device. That device can be anything. It can be a CD drive, it can be pen drive, it can be anything, or it can be a file at which place you want to write that particular thing. Okay, this interface is implemented by all the input-output classes that write to a string, like buffered output string. Okay. The methods defined by input stream are integer available returns the number of bytes of input currently available for reading. Void close. How many number of bytes of input are available for reading? Void close closes the input source. Further read attempts will generate an input output exception. Okay, whenever you are closing the input stream, after that, if you are trying to read that particular stream, it will throw an input-output exception. Void mark integer number of bytes. Places a mark at the current point in the input stream that will be remain valid until number of bytes are reached. Okay, like reader mark in your bookmark, it works like that. We will mark at the current point and up to whatever number of bytes are read, that string will be remaining valid. Boolean mark supported returns true if mark reset is supported by the invoking string, otherwise false. Integer read returns an integer representation of the next available byte of input. -1 is written when the end of the file is encountered. Integer read byte buffer attempts to read up to buffer.length bytes into buffer and returns the actual number of bytes that were successfully read. Okay. What is the difference between first read and second read? First returns an integer representation of next available byte of input. Okay, if the end of file is there, -1 it will be given. And the second read function attempt to read up to buffer length, bytes into buffer, and returns the actual number of bytes that were successfully read. -1 is written when the end of file is encountered. Read byte buffer integer offset number of bytes attempts to read up to number of bytes into buffer starting at the offset buffer offset, returning the number of bytes successfully read. Otherwise, -1 is returned if the file is ended. Void reset resets the input pointer to the previously set mark. Long skip long number of bytes ignores, that is skip number of bytes of input, returning the number of bytes actually ignored. Most of the methods in table 1 and 2 are implemented by the subclasses of input stream and output stream. The mark reset methods are exception. Notice their use of lag thereof by each subclass in the discussions we will see afterwards. Okay, so mark and reset are the methods, are exceptions, means those are not implemented by subclasses of input stream class and output stream class. Okay, because there are some advantages or disadvantages of the mark and reset functions, so that we cannot those are not implemented by those classes. Okay, so marking is just like what, if the mark is supported, otherwise it is not, like this. Output stream methods, void close closes the output stream. Further write attempts will give you exception input output. Void flush finalizes the output state so that any buffers are cleared, that is it flushes the output buffers. Okay, so whatever is there, it will be returned to output stream. It can be anything. Void write integer b, write a single byte to output stream. Note that the parameter is an int which allows you to call write with expressions without having to pass them back to byte. Okay, it will write a single byte b to output stream. Parameter is an integer which allows you to call write with expressions without call. Notice that parameterized integer which allows you to call write with the expression without having to pass them back to byte. Okay. Write byte buffer writes the complete array of bytes to an output stream. Void write byte buffer integer offset integer number of bytes writes a subrange of number of bytes from the array buffer beginning at buffer offset. Then file input stream. The file input stream class creates an input stream that you can use to read write from a file. Okay, so input stream can be created, so whatever is there in the file written so that you can read it. Its two most common constructors are file input stream, file object. First is having file path as a parameter, and second is having file object as a parameter. Okay, either can throw file not found exception if file does not exist, whatever you have to read. Okay, file path is the full path name, file object is the file object that describes the particular file. The following example create two file input streams that use the same disk file and each of its two constructors. First is one disk file auto execute.bat with having the file input stream object created FO. Then file S new file auto exec.bat and file input stream. First of all, file object is created in second thing, and then its object file input stream F1 is created, and that F is passed over here. Okay, in the first one directly the path is given. Second is, first of all, the file object is created with the particular path, and then that file input stream object is created. Although the first constructor is probably more commonly used because it is completed in one line, the second allows you to closely examine the file using the file method before we attach it to a input stream. Okay, when a file input stream is created, it's also open for a reading. Second one constructor will closely examine the file first, so that file methods can be applied to this object file F. Okay, in this case you are going to have only the file input streams method applied to this. But here file object is created. So whatever file methods are there, like get name, set name, get date created, or absolute path, real path, whatever is there, that should be that will be applied to this object. Okay. But this is the very commonly used thing, and this is very rarely used, but this gives you very much advantages. When an file input stream is created, it is also open for reading. File input stream overrides 6 of the methods in the abstract class input stream. It overrides the methods given by the input stream because it extends the input stream class. Mark and reset methods are not overridden, and any attempt to use a reset on file input stream will generate an input-output exception. There are two methods available, as we have seen, mark and reset. These methods are not overridden because in any attempt to use this method or override this method reset on a file input stream will give you input-output exception. Now we will see how to read a single byte, array of byte, and subrange array of byte from a file. It also illustrates how to use available to determine the number of bytes remaining and how to use skip method to skip other unwanted bytes. Sorry. The program reads its own source file, which must be in the current directory, okay, whichever you are processing. So we will see now file input stream demo. You are importing the Java.io package because we are exploring this one. In the previous example, previous chapter, we saw the Java util package because those were utility classes. Those were not part of your collection framework. And here we are exploring the input-output package. So we have to include this package java.io. Then file input stream demo. This is the main method throws the input-output exception. First of all, we create size integer variable and a new file input stream demo.java. Total available bytes f.available. Then n is equal to size divided by 40. First n bytes of the file, one read at a time. Then how many bytes of file one read at a time? Those are decided by the whatever available bytes divided by 40. So these many can be read. And in the for loop, we are reading each and every character one by one. Still available, f.available, reading the next n with the one read b. Okay. Byte b, new byte n. So this is the byte array with the n given. So n is what? Size divided by 40. If f.read b is not equal to n, so couldn't read those bytes, and new string p, 0, n, still available f.available, and skipping half of the remaining bytes, skip size divided by 2. Okay, so only half file will be read, other will not be read, those will be skipped. Reading n divided by 2 into end of the array. F.available will be seen now. F.read b n divided by 2, n divided by 2, not n divided by 2. Then couldn't read this much bytes. And then new string b0 b length still available again. Total available bytes are 1433. First 35 bytes of the file one read at a time. Okay. Then still available 1398. So 35 bytes we are reading at a time. Still available are 1398. Reading the next 35 with one read b, code java.io. Okay. First we have read demonstrate file input stream.input. Those are 35 bytes. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, and 32. Okay. So at most 32 bytes are read, and after that next 35 with one read, port java.io. Here port java.io. Next 35 with one read, class file input as. Okay, so these are the 32 or 33 maybe, and after that available as 1363, skipping half, still available 82, reading 17 into the end of the array. Okay, so whatever are remaining, we will reading 70 only up to the end of the array. Code java.io, read b is not equal to n, then curly bracket and s, still available 665. How to read three ways: to skip input and to inspect the amount of data available on a string. Okay, so any input output exception we will handle in the upcoming video, upcoming PPT slide that might occur by throwing input output exception of out of main, which means that they are handled by Java virtual machine. Okay, this is fine for simple demonstration programs and for small utility programs that you write for your own use, but commercial applications will normally need to handle input output exception within the program. Okay, so what is the note over here is, okay, so whatever example we have seen till now, handle input output exception by throwing input output exception out of main, and that exception will be handled by Java virtual machine. This is the one part. And second part is, for small programs it is okay that we are throwing the input output exception out of the main, public static void main. You are throwing out of it, it will be handled by Java virtual machine. But for small programs it is okay, but commercial applications worldwide use this application. Commercial applications means whatever application they are generating revenues, because any program, any project you are outsourcing, you are selling your Java application, Java program, you are taking money out of it. Okay, for example, you are selling your project, for example, to 10,000 rupees or 20,000 rupees. So whatever exception you are going to handle, those should be handled. If you are having the commercial applications, you should handle the input output exceptions within the program itself. Okay, you are, if you are having your, if you are generating revenue out of your program, whatever exceptions will be there, you should handle by your own. Okay, small utility programs and your practice programs are okay that you are throwing the exception out of main. What does that mean? If you are throwing the exception, anything other, anybody other will handle the exception, but this is not the case for worldwide uses application. You have the responsibility of handling your exception, your own exception. Okay, next, file output stream creates an output stream that you can use to write by your particular file. So constructors are file input stream, file path, file input output string, file output stream, string file path, file output string, file object, file output stream, file path boolean append, file output stream, file object boolean append. They can throw a file not found exception. What are all should all will throw a file not found exception. File path is the full path name of file. File object is the file object that describes the file. If append is true, the file is open in the append mode. Creation of a file in output string is not dependent on the file already existing. Okay. File output stream. For file input stream, we were reading from a file, but here we are writing to a file. If you are writing to a file and if there is no file existing, the file will be created automatically. So you no need to worry if file existing or not. Okay. And append is true. A file is open in append mode means what? Whatever is written in the file will not be overwritten. Okay. The data will remain intact. Whatever you want to write to a file, that will be appended at the end. So most of the times you will use, I recommend append as true, so that your original file will remain intact, your original data will remain intact. Okay. For example, if I have one file example.txt at particular location and I have written to it, my name is Suvarna, full stop. Okay, and next time I want to I want to write to a file using file output string, like I live in India. Okay, so I have to append that at the end. So what I will do, I will make the append as true, so that my original string, my name is Suvarna, will be intact, and the total new file data will be my name is Suvarna and full stop I live in India, full stop, like this. Okay, file output stream will create a file before opening it for output when you create the object. Okay, if the file does not exist. In the case where you attempt to open a read-only file, input output exception will be thrown. So make sure if you want to write to the file using Java programming language, what you will do first, you will first check uh, by going to Windows environment, go to file, right click it, check the properties of file. If it is having the read only property set as true, then you cannot write to a particular file. Now we will see the example that creates a sample buffer of bytes by first making a string and then using the get bytes method to extract the byte data array equivalent. It then creates three files. First is file1.txt. They will contain every other byte from the sample. The second is file2.txt, will contain the entire set of bytes. So what we are going to do here is we will create a sample buffer of bytes by first making a string and then using the get byte method to extract the byte array equivalent. First one file is file1.txt, will contain every other byte. Second is will contain the entire set of bytes. Third is will contain only last quarter. Source is now the time for all good men to come to the aid of their country and pay their due taxes. Okay, and buffer is source dot get byte. First of all, we will get the byte from source to a buffer, byte buffer. What is source? Source is the string. This is the source. This is the string I want to write to a particular byte. So I will get the bytes to a particular byte array called as buffer. Okay. Then I will create output string object f0, and an output stream I want to write to a file that name is file1.txt that should be residing in your current directory. Make sure it. Okay. And that file should not be read only. It should have all properties set to true. Then from 0 to buffer.length, incrementing by 2, f0 dot write buffer of I, then f0 dot close. So from 0 to length, incrementing by 2, we are writing a particular string that is for to particular file1.txt buffer of I. So whatever is written to 2 characters, I am writing no. Then in the next iteration, W space. In the next iteration, I am writing IS is. In the next iteration, I am writing space and T and so on. Okay. Likewise, we are taking two to indexes. Then output stream F1. Every other byte means what? We are incrementing by 2. So N will be there, O will not be there, W will be there, space will not be there, I will be there, S will not be there. Okay. So depending upon the incrementation, if you are going to write over here 3, so 3 characters will be there, skipped. N, O, W will not be there, every third character will be there, space will be there. So output will be N space. Okay, then I, S and space is skipped, then T and so on. Then next is file2.txt, f1.write buffer, whatever is there buffer, and then close. And file3.text, f2.write buffer, buffer length minus buffer length divided by 4, and buffer length divided by 4. So third one will contain only the last quarter. So buffer divided by 4 will be there. So this is the file1.txt output. Okay. Then file2.txt will have all the data, and file3 will have the only last quarter and pay their due taxes. Okay. So depending upon your choice, you can write to the file. Okay. This is the motto of your program. Byte array input string is an implementation of input string that uses byte array as a source. Two constructors are there, each of which requires a byte array to provide the data source. Okay. implementation of input stream that uses the byte array as a source. And array is the input source. Start and number of bytes are two parameters extra in the second constructor. It creates an input stream from a subset of byte array that begins with the character at particular index specified by start and number of bytes long. Okay. Now we will create a byte array input stream, initializing them with a byte representation of alpha bit. Okay. TMP ABCD EFG XYZ ABCD EFG HIJK LMNOP QRSTUV WXYL. Okay, all the characters are included from A to Z. Then byte array is taken. Byte array input stream. First is on the byte array we are providing, and is having all the characters, and second is having new byte array input stream B0 to 3. 0 from 0, 3 characters long, 0, 1, 2, 3. Okay. Input 1 object contains the entire lowercase alphabet, while input 2 contains only the first 3 letters. Byte array input stream implements both mark and reset methods. If mark has not been called, then reset sets the stream pointer to the start of the stream, which is in this case is the start of the byte array passed to the constructor. Okay, so mark and reset first of all are implemented, but if the mark has not been called, then reset will set the stream pointer to again start of the stream. Okay, the next example show how to use reset method to read the same input twice. After iteration is done, reset to 0. Index will be starting with 0. We read and print the letters ABC once in a lowercase and then again in uppercase. So first of all, 3 letters are provided, ABC, then new byte array input stream B, then from 0 less than 2, 3 characters we are reading 0, 1 and 2. C dot in dot read. So in is what? Byte array input stream, new byte array input stream B. So we are reading the character one by one. If it is not -1 means end of file is not encountered, end of input is not encountered. If I is equal to 0. Okay. Then we are printing character representation of C. Else character to uppercase character C and input dot reset. Okay. So first we will write down in a lowercase A, B, C, and next will be capital A, capital B, and capital C. Okay. Character dot to uppercase will change it to uppercase characters. Okay. The first reads his character from the stream and prints as is in lowercase, and then reset the stream and begins reading again, this time converting each character to a uppercase before printing. Okay. Byte array output stream is an implementation of output stream that uses byte array as the destination. Byte array output stream has 2 constructors. One is default and second is number of bytes. Okay. How many bytes you have to write to into the array. First one, buffer of 32 bytes is created. The second buffer is created with the size equal to that specified by number of bytes. The first one will be of 32 byte length, and second one is buffer will be the length of particular number of bytes. Those are given by you or a programmer. Buffer is held in a protected buffer field of the byte array output stream. So this state is protected. It is not public. The buffer size will be increased automatically if required. The number of bytes held by the buffer is contained in the protected count field of byte array output stream. Actually, you are creating the 32 byte length buffer. Okay, and actually how many bytes are actually held in the buffer are decided by the count field of byte array output stream. Now we will see the example. Import java.io package like this, and then object is created, then string, this should end up in the array byte buffer s dot get bytes. So f dot write. So byte array output stream object dot write to particular buffer. Okay. So buffer as a string and f dot toString we will display into array b array buffer to byte array from 0 to byte dot length. We will create we will cast a particular each and every character to a character and then we will print it. Okay, to an output stream and new file output stream txt.text. Okay, test.txt. Then write to particular f2. So whatever we have read f dot write to f2. So what is f over here? This is f. F, that is a byte array output stream object, and write to file f2. You will whatever is there, it will be write to particular file, and file will be closed, f2 dot close. So again reset, and from 0 to 3, 0 1 to f dot write x and f dot toString. Okay, when you run the program, you will create the following output. The 3x are end up in the beginning. Doing a reset, buffer as a string, this could end up in the array into array, this should end up in the array to an output string. Doing a reset, triple X. This example uses the write to convenience method to write the contents of f2 text.txt. Why it is a convenience method? Because you can write the data into particular file as and when needed. Okay. And what is reset? Reset will again set the index to 0. Okay, doing a reset x and x. So all the data is reset it like x and x. Okay, examining the contents of test.txt created in the preceding example shows the result we expected. This should end up in the array. Okay, so while we will open the file return test.txt, we will see this example in the practical part so that you will understand it very clearly, very properly. Okay, so whatever program we have run till now, the output will be returned to test.txt and this should end up in the array. Now filtered byte stream. Filter streams are simply wrappers around underlying input or output stream that transparently provide some extended level of functionality. Okay, those are wrappers around the input or output stream. And second thing, that transparently provides some extended level of functionality. So input and output streams are there, and filtered byte streams are wrapped around the input and output streams, and they have extra functionality. Extended means extra, something extra. These streams are typically accessed by methods that are expecting generic stream, which is a superclass of the filtered stream. Okay, whatever method those expect a generic stream, those will access this type of filter byte stream. Typical extensions are buffering, character translation, and raw data transmission. Okay, when you need a buffering, character translation, raw data translation, you will require this type of filtered byte stream. Okay, the filtered byte streams are filtered input stream and filter output stream. So constructors are filter in output stream OS, filter input stream, input stream is. These methods provided in these classes are identical to those in input stream and output stream. Okay, methods will be the same. Only the filter output and filter input will be the wrapper. Okay, buffered byte stream. For the byte-oriented stream, a buffered stream extends a filter stream class by attaching memory buffer to the input-output stream. Okay. So what is this? For the byte-oriented stream, buffer will extend filter stream by attaching memory to the input-output stream. So buffer is added at the attachment. This buffer allows Java to do input-output operation on more than a byte at a time, hence increasing the performance. Okay, why the buffer is added? To speed up the performance. Because the buffer is available, skipping, marking, resetting of stream become possible and easier. Okay. What is the use of this buffered byte stream? It extends first of all filter stream, and it attach a memory buffer to the input output stream. So whatever operations, skipping, marking and resetting of the stream become easier. Okay, and your speed or time complexity is reduced. Speed is increased. The buffered byte stream classes are buffered input and buffered output stream. Pushback stream also implements a buffered stream. Okay, pushback input stream. Next is buffered input stream. Buffering input output is a very common performance optimization. Okay, so that your time complexity is reduced, your performance is increased. Java's buffer input stream class allows you to wrap in input stream into buffer stream and achieve that performance improvement. Two constructors are there: buffered input stream, buffered input stream. First is having input stream object and second is having input stream and buffer size. First form creates a buffer stream using a default buffer size, typically 32 bytes. The second is size of the buffer is passed in buffer size. Use of sizes that are multiples of memory page, disk block and so on can have a significant positive impact of a performance. So intentionally you can pass size of buffer size that is multiples of memory page, disk block and so on can have a significant and if you are specifying the particular buffer size that is in multiplies of this, it will more positively impact of your performance. Your time will be reduced drastically. Okay, implementation dependent, because your PC is different, another person is having laptop. This system is hard disk drive size, memory size, RAM size is different. So depending upon the system, you can specify. So specify the buffer size. So it is the implementation dependent. Okay. And optimal buffer size is dependent on host operating system which is you are using. It is Windows 7 or Windows 10 and so on. It is Linux or it is Ubuntu. Depending upon that, the amount of memory available and how the machine is configured. Okay, as I have explained right now. So it is your choice. So generally you can use this if you want to your application of your program to be used very vastly or worldwidely. You can use the first constructor, and if you want to give the buffer size, that buffer size is dependent upon the PC to PC. For every PC that buffer size can change, and if your buffer size does not matches the memory available, it can throw the exception also. So most probably you can use the first one. To make good use of buffering does not necessarily require quite this degree of sophistication. Good guess is for sizes around 8,192 bytes, and attaching even a rather small buffer to an output stream is always a good idea. Okay, so generally the bytes are this much, and if you want to specify the byte size, you can take a small amount of this and you can specify it as a buffer size. The low-level system can read blocks of data from the disk or network and store the results into your buffer. Okay, so you can take also 1000 or 500 bytes also can improve your performance. Even if you are reading the data a byte at a time out of the input stream, you will be manipulating fast memory most of the time. Buffering input stream also provides the foundation required to support moving backward in the stream of the available buffer. So what it provides? The foundation required to support moving backward in the stream of the available buffer. Beyond the read and skip methods, buffered input stream also supports the mark and reset methods. This support is reflected by buffered input stream marked as supported returning as true. Okay, if mark is supported, it will return true, otherwise false. Now, following example contrive the situation where we can use the mark. Remember where we are in an input stream and later use reset to get back there. This example is parsing a string for the HTML entity reference for the copyright symbol. Okay. Here we will use two functions. First is mark, second is reset. First mark, remember where we are in input stream, and later use reset to go get back there to that particular location. This example parsing a string for the HTML entity reference for the copyright symbol. And this reference begins with ampersand and ends with the semicolon without any intervening white space. So whatever is there between ampersand and semicolon, the white space should not be there. The sample input has two ampersand to show the case where the reset happens and where it does not. Okay, so buffered input stream demo. So this is an ampersand copy. So in here it should not have any space, copyright symbol, but this is and copy not. So and copy semicolon is not there. So this is not a copyright symbol. Byte buffer. First of all, we will get bytes of this string. Then input stream byte array input stream object is created and this buffer is passed to it. Byte buffer input stream f is equal to new buffer input stream in boolean mark is equal to false. Okay. Still end of string is not encountered. Switch C. If it is and, if not marked, we will mark at a particular place, that is 32, and mark as equal to true. As mark is equal to false. Break. Then the second case is semicolon case. If it is mark is equal to false. Then print system.out.print, print, that is copyright, and else print the particular character. Okay. Case space, if mark is equal to false, and again reset to a particular location and print the ampersand. Else print the particular, get the particular character and print it and then break. If not marked, then print the character and break. Okay. This example uses mark 32, which reserves the mark for the next 32 bytes read, which is enough for all entity reference. Okay. This is C copyright symbol, but this is and copy not, because and copy is not having semicolon over here. Okay. So this way we have completed some interesting classes like byte array input stream, array output stream, buffered input stream, filter byte streams, and introduction and uses of date space. Okay. Main thing over here is in file input output. All the class names feels or seems to be same. When you will practice and when you will use them very much frequently, you will remember which class is used for which thing. Okay. So we will meet you in the next session with more classes. Till then, you can enjoy input output in Java in detail. Okay. Create as many programs as you can. Use them in your own Java applications, small applications, and try to remember and you can also have or also take the functions and try to implement that functions on your code. Okay. So meet you in the next session. Thank you so much.